Spirit 12 is a fast, lightweight, custom-designed pinwheel-oriented quadcopter built out of carbon fiber. Spirit 12 is purpose-built to carry two 16-ounce water bottle delivery systems and a camera while flying the 10-mile obstacle course at an average speed of 45 miles per hour. Team Animus Ferus consists of 16 students and one faculty advisor. The design team is split into two sub-teams, the 11-member hardware team and the 5-member software team. The flight line team will include both team captains and the safety pilot.
My name is Fred Spinaji. I'm a team captain, and I've been on the team for 2 years.
Hi, I'm Ria. I'm one of the other team captains, and I've been on the team for 2 years. I will also be running GCS.
I'm Matthew Trimble. I'm the acting safety pilot, and I've been on the team for 2 years.
Team Animus Ferus has specified requirements and acceptance criteria based on the timeline of the competition. To optimize points, the team will use a maximum of 24 out of 30 minutes for mission time, appropriately distributed between each mission component. Takeoff and landing will be allotted 30 minutes each, and the craft will fly 10-mile waypoint course at an average speed of 45 miles per hour or 66 feet per second for a total navigation time of 14 minutes. This speed is attainable by Spirit 12 and was chosen to maintain the set timeline. For airdrop, the team determined an average of 2 minutes each, 90 seconds to locate and navigate to the target, and 30 seconds to drop the payload. To minimize mission time and implement symmetry into the drop system, Team Animus Ferus plans to complete only 2 airdrop tasks and allot a total of 4 minutes of mission time for the airdrop. Spirit 12 is a custom-designed quadcopter built from carbon fiber with dimensions of 65 by 65 by 18 inches and an overall weight of 36 pounds. The craft is fully powered by two 6S1P high-voltage 22.8 lithium polymer batteries wired in a 2S1P configuration to make a 12SIP system providing a maximum of 52.8 volts to the power distribution board. The batteries have a capacity of 17,000 milliamp hours, allowing Spirit 12 to have a maximum range of 7 miles and a flight time of 35 minutes. Spirit 12 is also equipped with 4 kDe motors and 24-inch propellers, each capable of generating a maximum thrust of 30 pounds for a thrust-to-weight ratio of 3 to 6 to 1. For airdrop, the craft uses 4 individual motors, all with dynamic braking to slow the descent of the airdrop payload to 10 feet per second. For communication purposes, the team Animus Ferus has chosen to use the Doodle Labs 2.4 GHz smart radios for reliable low-latency communication between the craft and ground control station. All data is received by the ground control station, which serves as the team's interface to control and monitor the craft during flight. This includes 2 computers, one for Q ground control and one for video feeds, and a counterpart radio to the one on board the craft, allowing the operator to send commands to the craft, adjust flight parameters, receive real-time telemetry data and video feeds, and execute mission tasks. Team Animus Ferus chose the Alvium 1800 U2040C camera for its excellent specifications. With a Sony IMX541 1.1-inch sensor, the camera boasts a 20 megapixel resolution at 21 frames per second with a global shutter. A global shutter camera was deemed preferable as cameras with rolling shutters tend to produce frame tearing when in motion. This camera, coupled with the 50mm DG series fixed focal length lens, captures the 8.5 by 11-inch target at 125 by 167 pixel resolution. Additionally, the Alvium blends well with the team's AI detection program, which consists of a dataset made up of images and automatically generated using Blender. This is a trade-off to using real photos, which are more realistic. However, using Blender, the team can generate more images, which is more effective for creating the large datasets needed to train the AI. Thus, due to the optimal size, weight, and performance for this price, the team chose the Alvium 1800 U2040C camera. In addition, to reduce setup time at the competition, the team decided to use the optical character recognition algorithm called OCR text. This software converts the waypoints into a text file and allows them to be directly imported into Q ground control. For the airdrop subsystem, Team Animus Ferus created 2 independent drop systems with individual motors, servos, and 58-gram 3D printing ring mounts to carry the water bottles. To deploy water bottles, the team built a clip that snaps onto the top of each ring mount. Each motor is connected to the craft's airframe and attached to the ring mount with a Kevlar string. A servo sits at the base of the ring in the default lock position to prevent the bottle from deploying. Each motor also maintains a steady resistance while unspooling by dissipating regenerative current from the rotation as heat, similar to common rheostatic braking methods, creating a lower and smoother rate of descent for the payload. Through experimental testing, the team used video analysis to calculate the most efficient descent speed without payload damage. 10 feet per second was determined. To communicate between team members, Team Animus Ferus used the Motorola EVX S24 digital UHF radio on 452 MHz. For craft-to-ground communication, the team used the Doodle Labs 2.4 GHz smart radio. The smart radio is capable of handling both standard vehicle telemetry and 5 video feeds from the craft while protecting all data with 128-bit AES encryption. It also creates resilient private wireless networks to mitigate any communications interference and monitor in-band interference with its built-in spectrum scanner to automatically switch channels. The expected bandwidth of the radio is 90 megabytes in optimal conditions and an average of 50 megabytes from 3 miles away. The team uses an R9 telemetry receiver and FR Sky Tyrannus to connect the safety pilot to the craft. The FR Sky receiver uses the 900 MHz band and employs frequency hopping spread spectrum to avoid interference from other communication systems. Team Animus Ferus' UAV Spirit 12 is a custom-designed quadcopter with a pinwheel layout. Due to the batteries and drop systems serving as limiting factors, Team Animus Ferus' main goal was to minimize weight while maintaining speed and range. Ultimately leading the team, they chose a quadcopter design with the smallest possible plates and spars. The weight-reducing endeavor was successful. Spirit 12 weighs a total of 36 pounds. In order to maximize thrust and retain efficiency, the team chose to use KDE direct dual-blade 24-inch carbon fiber propellers and 4 KDE 7215 XF 135 motors. This configuration outputs 120 pounds of thrust in a high thrust-to-weight ratio, allowing low throttle hovering and increased flight efficiency. Spirit 12 utilizes the HexCube Orange, a reliable and versatile open-source flight controller. Team Animus Ferus chose this cube due to its already integrated triple redundant sensor arrays, which greatly minimizes the risk of a sensor-related crash. The cube is mounted to a core carrier board, simplifies wiring by handling power distribution to sensors, ESCs, and several payload components. The Cube Orange also runs AUTOPILOT 4.0, which allows the team to perform fully autonomous flights in optimal condition. It also supports automatic grid search, simplifying mission planning when performing ODLC and AIRDROP tasks. This was the best choice available for the team due to its fast processing capabilities and finest sensors. For the obstacle avoidance challenge, both the safety pilot and team captain will use direct sight to detect any potential obstacles. Then the ground control operator will take appropriate action, likely through lowering or increasing altitude. This was the chosen solution for obstacle avoidance as it gives the team a good sense of the immediate airspace around the aircraft while remaining relatively inexpensive and simple. An alternative considered was the implementation of 2 ladder towers, which was eventually scrapped as the trade-offs increased craft weight and drag outweighed the benefits. Thus, the current method was chosen to be the best solution as it gives a 360-degree field of view. In emergency cases, Team Animus Ferus will perform a manual takeover to avoid collisions. Originally, Team Animus Ferus opted to use a pinwheel-style aircraft similar to the team's previous crafts. However, it was quickly decided that such a craft would not be able to meet the demands of the competition, namely the increased payload weight and waypoint distance, thus incentivizing an H-pattern airframe design. Due to time constraints and delay in part shipments, the team used our pinwheel-style aircraft Spirit 12. The team also considered multiple drop mechanisms, focusing on finding the most efficient solution. This introduced 2 possibilities, a rotating drum drop system and a slide dispenser, which required only 1 motor compared to the 2 present in the current system. However, the size, weight, and general complexity were far too great trade-offs for the team. Lastly, the team finalized a new camera, as previous models were deemed inefficient for the demands of the new competition. A primary alternative was the PixelLink PL D7-920 camera, which was equipped with nearly identical specifications to the team's chosen camera, Alvium 1800 U2040C, with the most significant difference being the price. The most significant developmental risk is the improper onboarding of new team members due to an insufficient understanding of operating machinery and hazardous components. To minimize this, the full team underwent a safety protocol seminar led by the safety officer. All individuals received direct instruction from senior members and thorough documentation. Those handling hazardous components such as LiPo batteries also received proper training. To further prevent injury, the team employs equipment such as anti-spark connectors, LiPo-safe bags, Class D fire extinguishers, and both a first aid kit and complete trauma kit. Team Animus Ferus notes the mission risks of injury, communication interference, in-air collision during flight or setup. To minimize risks, the team follows strict protocols, including all members follow pre- and post-flight checklists. All team members are also required to stand back from the armed craft. Only the designated safety officer has the authority to arm and disarm the UAV to prevent injury. Additionally, the safety pilot is also connected to the craft and can take control if necessary. In the event of total communication loss lasting more than 30 seconds, the UAV returns to launch and automatically lands. Using the Alvium 1800 U2040C, the drone flies a U-shaped path over the airdrop boundary. During this 8-minute process, the ODLC will provide Spirit 12 with the location of each of the 5 possible drop locations. Team Animus Ferus threshold is 10 ppi. During testing, the camera produced frames with 15 pixels per inch and 165 pixels for each target. Because the craft will be flying over the targets and responding in real time, a camera with a global shutter prevents frame tearing in videos. Team Animus Ferus was unable to test ODLC performance, but based on a synthetic dataset, the program recognized a target 78% of the time. On average, the model was able to detect objects 85% of the time with 85% accuracy. The model's average false positive rate is 8%, and the average false negative rate is 14%. Team Animus Ferus unit tested the tethered descent drop system by repeatedly dropping the payload system in a 20-foot stairwell. The airdrop is a one-speed system, so the team didn't conduct additional testing to calculate the timing of the descent before integrating it into the craft. Team Animus Ferus conducted a total of 12 airdrop tests with a success rate of 83%, as all drops placed the water bottle within 8 feet from the target circle. Team Animus Ferus performed various simulation and integration tests to collect data on the range, packet loss, and throughput between Spirit 12 and the ground control station. The team determined the throughput and range of the Doodle Lab system by streaming the video feed over the mesh network and separating the craft from GCS by 1,000 feet. The data collected in testing showed an average bandwidth of 90 megabits per second in optimal conditions and maintained an average of 50 megabits per second of throughput. Team Animus Ferus has not yet completed a full mission test including autonomous flight, waypoint capture, ODCL, and airdrop. During these tests, the team plans to capture all of the required waypoints with an average accuracy of 100% with an estimated total flight of 20 minutes. The aircraft can reach a top speed of 60 miles per hour with an average speed of 40 miles per hour. Team Animus Ferus' autopilot tests have successfully identified the waypoints using the team's OCR program, OCR Text. The team is able to scan the page provided with this OCR, which automatically turns written waypoints into waypoints Q ground control can understand. After running several tests, the probability of successfully running these coordinates is 94%. Once in the air, the team uses the ODLC to identify the 5 targets and drop payloads from a safe height. This is done by scanning the field and sectors, locating the coordinates of the target, dropping the payload, and then continuing to the next sector to scan. The team has not yet been able to test the percentage of targets trialed and the percent of time bottles were safely dropped. Team Animus Ferus' obstacle avoidance allows the craft to avoid collisions 100% of the time. This is maximized by relying on the human element where both the safety pilot and the team lead have direct line of sight of the craft. Flying at an average speed of 40 miles an hour, this gives the team 0.7 seconds to react to an observed UAV in the flight path. Mission testing with Spirit 12 will consist of flying waypoints, performing airdrop tests, and attempting ODCL targets. The craft will use ODLC tasking to find the locations of the 2 targets. It then performs an airdrop on the targets. As of now, Team Animus Ferus has not yet completed a full mission test, but plans to conduct multiple full mission tests within the next month.
Yeah. I'm Matthew Trimble, safety pilot for Team Animus Ferus, and this is our 200-foot manual takeover demonstration. Clear to arm. Arming. Confirm loiter. I'm Matthew Trimble, safety pilot for Team Animus Ferus, In this flight, we'll be doing 1,000 feet away from the safety pilot in manual and coming back and doing a manual landing.
Approximately 6 miles into the 12-mile flight attempt, the Mavic Pro recording the flight ran out of space on its onboard SD card, resulting in the remainder of the flight recording being lost. However, the remaining mile flight was captured by the GCS mission planner. After flying 7 of the 12 miles, the battery voltage was too low to continue a safe operation, causing the team to initiate a return to land for Spirit 12. Currently, the team is looking into ways to add additional batteries to Spirit 12 to extend the in-air flight time to achieve the 12 miles. Team Animus Ferus is confident in its ability to successfully complete the mission objectives. The team looks forward to demonstrating the capabilities of the UAV Spirit 12, a pinwheel-oriented quadcopter. The pinwheel design allows the team to achieve a maximum speed of 60 miles an hour in a range of 7 miles. The team cannot yet predict the mission demonstration score, as a full mission test has not yet been completed. Thank you for watching.